Morning, everyone.
Good morning, everyone.
Let's give everybody just a minute. See. Okay, maybe let's get going. So, Michael, last time you had a question about which part model to create next, and I think the way you're thinking about it is getting HBM3 done first, then HBM4 would be the right approach.
All right. Actually, we started on the HBM4 because Micron has actually told us that since that's in the process of getting published, the HBM4E is in the ballot and HBM4 is in the publication office. They said, let's just try and get this done so that we can release the part model for the HBM4 at the same time. Nevertheless, David, we are actually, we had a meeting last Friday, and we will have another meeting next Friday, in which we hope we will have completed the HBM4, and then we will start on the HBM2E, and we will take those to the committee on in June timeframe. And hopefully, if they're approved, we will get both of them released at the same time.
Sorry, you said HBM2E or 3E?
Well, okay, so just bear with me for a second. So we have HBM1, 2, and 2E complete.
Yes.
And then we started to look at the structures for HBM4. Now, the way we created the patterns for HBM1, 2, and 2E was based off a purely physical structure, right? And when we started to do that for HBM4, the group that was working on it said, yeah, this is not so easy to figure out how to do it. So Micron gave me this document here, and I want to share this with you. And this is what JEDIC has created in terms of a pattern for the HBM4 with a footprint A and a footprint B. And here you see that you have an array structure for going from A1 to HA308. And over here is the other one is A1 to HA3348. So there's a few extra columns in the footprint B. And here they say, you know, these patterns were mapped to electrical blocks.
Yep.
So we're revising our approach in how to create the patterns with a view to look at, do we create two sets of patterns, one for the physical structure and one for the electrical structure. So the electrical structure could be done with the regions and with all the regions, right? Because you can create a small region and nest one region within the other and then connect it to all of the electrical content. Or you could do it based on the terminal pattern, create a bunch of terminal patterns and group that into pattern group and then assign it to the electrical patterns. Mm-hmm. And so we're going to explore both of those options during the course of next week and take a look at when we plot these images. Should we, question one for ourselves, should we create a block for dedicated to each of these individual blocks that you see here? So by creating one here, I'm assuming that every place where you have D word is going to be the same pattern in terms of the array that is populated and the missing terminals that's in that array. And if that is the case, that might be one way of doing it, right? Create this, duplicate it for here, 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 group it into a pattern, duplicate it for here, put that into a pattern, and then replicate it across this world here, right? That's one option. But until we see what's missing here and what's missing here, until we validate that the patterns that are missing are consistent between these groups here, obviously we need to do it throughout the whole lot to be absolutely sure. We are not 100% sure yet how to create the group. The second way to do it is check to see if the A word is the same structure as the D word. And maybe what we'll end up doing is taking these three and putting that into a pattern and then duplicating it for 3 across, 2 down, taking that pattern and duplicating it into this array. So I don't know the answer to that yet, because each time we duplicate it, we want to make sure that we name it the same name here. This one looks very simple, right? These 4 blocks here. This looks very simple as a pattern to group. This looks very simple. We did that for the UCIe, so that was easy. This one here should be simple, and these up here should be simple. And if we do it this way, then it's all defined by the standard. The patterns are even defined by the standards, and it should be very easy for people to understand it. So we're thinking of that approach right now.
Mm-hmm. Yeah.
Does it make sense, Cynthia? Do you think you have a better idea?
No, it makes sense. I don't know how things look to be able to tell you what might be better, but I think definitely you're going to end up with a situation where the D word plus the 2 D words plus A words are at the end of the day end up being one pattern. How it's constructed doesn't matter, right? But that triplet is, at least if I remember HBM3 correctly, that triplet is the same all over the place. So it's
so
just
does D word 0 and A word 0 and D word 1 for channel 28, does all that map into one chiplet?
Not one chiplet. It maps into one pattern, and then you replicate that pattern.
So is this entirety, everything from A1 to HM308, is that considered one chiplet?
Yes.
Okay. All right. That's good to know. All right. Okay. Within D word 0, do you tend to have different terminals? For example, a data bus, a control line, etc., etc.
No.
So
one channel. So one channel is. Let me put it this way. If you take one channel, that's your one unit. Channel 28 is going to be same as channel 29, same as channel 30, 31, and so on, right?
Right.
Now,
so channel 28 then would be made up of a mixture of data buses, address buses, control lines, etc.
Yes.
Okay. So if we do it in that way, then the references to the electrical specification from channel 28 would be the same references to the same specifications for all the other channels.
Yeah.
Okay, right. So that makes it highly efficient.
Yeah. Now, now I don't know one level lower whether D word 0 and D word 1 are going to have exactly the same layout or not. Maybe not. I had to.
So this is what we figure out when once we plot it. We can see if they have the same structure. But even if they don't, if they do have the same structure, I can duplicate it. If they don't have the same structure, I create a separate pattern.
Yeah.
But once I create the separate patterns, I group all of the stuff into a pattern group, and I call that channel 28. And then when I duplicate that pattern group, I can rename them to different channels.
Yeah.
Yeah. Okay.
I think that would be the.
All right. Okay. That's
easier approach.
Right. Now, I also see that I have a feeling that I'm more than a feeling now at this stage. I'm going to show you this here.
Actually, quick question before you get to that. For a given pattern, does JEP30 right now allow a name to be specified, like a human entered name?
So just about to get to that same question, because I want to see that channel group 1, channel group 2, etc. Right? Pattern. So each pattern has its own name at that pattern level, right? But when I say that, if I create a pattern for D word, right? I would not have 0 on it at this stage, right? And A word and D word, right? So when assuming that this is different to this one, I would create the pattern with the name D word.
Right, but we could have user-defined PIN names and also the instance name. So, David, you were talking about the instance name?
Yeah. I'm talking about basically that pattern to have a human name, human specified name that doesn't mean anything other than to humans.
Yeah. Okay.
Yeah,
but
yes,
we can.
Yeah.
You can. What I was trying to figure out there is, as I go from here to here, right? The D word 0 is the same, but in this case, when I select those 3 to make one pattern group, I could call that pattern group channel 28. Now, when I duplicate that pattern group 3 times to the right, I really want to specified that this instance is 24, this instance is 20, and this instance is 16.
Yeah.
And in its current method, I don't think I can do that. I think
Yeah, you should. Yeah, you probably. Yeah, you should add the names to the instantiations.
Yeah, you see this one here is an int x. So an int x is, in this case is 3, and int y is equal to 2. How do I specifically name the instance that is here, for example, channel 25? I cannot do that right now unless I duplicate it at a 1-to-1 ratio.
No,
So,
you can just add one more entry.
Yeah,
So
I have to.
says for X1, Y1, name is that. For
Yes.
X2, something like that.
Yeah. I have to, but I have to make a small modification to the schema to do that. Yeah, but so I will do that as part of the next release submission to the ballot process in June. I mean, this is why we're creating all of these part models now in CDX, so to help make all this even more robust.
Yeah, you can add, when creating the XML, you can add the entry. Just the schema is not going to validate it. It's not going to contain it. So
yeah, that's fine.
Yeah.
All right. Yeah. So so you'd like HBM3 done as well. So right now, if we finish this one, hopefully by next week, we should be able to, I think the HBM3 will be quicker because we'll have, gone through the process a few times now,
Yeah, I would, I don't know how much HBM4 has changed from HBM3 beyond adding the second column of channels, right? HBM3 is just one column of channels. So within the channel, is there much change? I don't know. I suspect not. So HBM3 might be just a kind of a reduction in the, you just remove a few things from the.
So you're thinking
XML,
all of this is the channel that disappears?
Yeah. Well, the other channel technically, right? Because it goes, HBM3 goes from 0 to 15. So you'll remove the 16 to 31, and that will get you very close to actual HBM3.
Oh, so HBM3 goes this way. Right. So in that case, I'd be removing this set. So where does the BDCC then move over? Where did that go? Because I have 5 channels.
I don't know off the top of my head, but I think it stays right there.
Oh, it stays right here. So you still have 4 on this side and 1 on this side. Okay.
Yeah.
Well, that's we can look into that.
Yeah. Maybe. Yeah. I think things are around the channels, things may have changed a little bit more than being that simple, just removing one column. I don't know what's in HBM4 right now, but the channels, which is the hard work, should be pretty much the same.
All right. So I at this point we're aiming to have it ready for next Friday evening time is when we have the meeting with the JEDIC team.
Okay.
But morning time we could present it to you as well, because if we're not ready, we'll have to cancel the other meeting, right?
Yeah, sure. Yeah. Okay. Yeah, that would be awesome. Yeah, we can take a look, see how it looks. Yeah.
Okay.
This is good.
All right, I stop sharing there then.
And you're saying the HBM4 standard is in the publication office. When would they officially publish it?
I heard that when I asked for last week, it was going to take a month for it to get finished. So that should have been middle of May, early May.
Okay. How much changes are they making to the? I'm curious about the process. When you submit something to the publication office, are they rewriting something or just?
And I'm not 100% sure in terms of the memory flow. For part model stuff, I do all the preparation for the publication, and
Okay.
I hand over the stuff to them, and they just simply put it onto the website.
Okay.
Because in the part model document, there's so many different. I want to retain the different colors for the different XML structures of data, and so having that level of formatting, it's better for me to do that. For anything that's not a part model file, it has to go through a publication team inside in the JEDIC office, and they review it for correctness of details and formats and styles and fonts and all of that stuff. And then they go through and release it. The memory modules has an additional extra type of content because they have Excel files. So I'm not sure what else they do, or if the committee themselves does that.
Okay. Okay. Somebody creates the actual Excel files and things like that.
Yeah.
Okay. Well, creating the Excel file for this is, I can see how it's going to take a month.
Well, look, you think that complicated? Look at this one. Where are the content? HBM4. Yeah.
Yeah, the HBM4 was what I was talking about.
Yeah, look at that, and that's like painfully slow. To make sure you get that pattern right.
Are you able to share this if it was voted and it's approved and it's just a matter of publication? Are you able to share this or not yet?
No, not now. I'm not able to. I'm showing you this here on my screen, but technically I'm not supposed to be showing this to outside of JEDIC group. The fact that we have an MOU with you.
Yeah.
I can ask Emily if I can share it with yourself, but you would have to make sure you put it onto the the restricted site for
Yes.
that associated with JEDIC
Okay.
and OCP.
Okay. Yeah, that's fine. If you do you want to zoom in a little bit to one of the channels, and I can eyeball the bumps and tell you how different they are from HBM3. Yeah, this is just the power and the direct access. The direct access is different. I can tell you that right now.
So this is where you had the D word 0, A word 0, D. I think. I'm not sure.
Okay, hang on. Yeah, this is same as HBM3.
It's HBM3. Okay.
Yeah. This is same as HBM3. If you go up a little bit, I can tell you about the power.
That's at the top now.
Power is a little bit different. Yeah, power is a little bit different.
Footprint A.
But a little bit meaning maybe a couple of rows of bumps are missing, things like that.
So here, what we're seeing is A1 to K. A189. So A189 is this one. To it's actually all the way over to 306. So if we just take it to size 202, so this then is the block that's directly over D word 0. And so D word 0 belongs to
no, but power is not going to be related to the channels.
It's not. right?
Yeah, yeah. The power is its own beast. It's always been its own beast.
Oh, okay. I made its own mistake there. That's the the thickness of the channel.
Yeah, yeah. But no, the next one over is different. Unless, yeah, and yeah. I don't know. The soul
It is different because immediately you see that there's an offset of 1.
Yeah, but it's symmetrical. If you take the two channels,
It's
then
not symmetrical either, because look at this section here. This section has a block that's in the middle that's not populated.
yeah, but if you take half of that block, basically the width of the two channels.
The width of the two channels, which is here.
Yeah, that one is symmetrical to the next one over. It just flipped.
Yeah.
Actually,
Okay.
no, it's not. It's one. No, it's not following. And it's kind of flipped, but then it follows the new rows.
No, it's not. No,
Yeah.
not
Yeah,
quite.
yeah.
Not quite.
Yeah, not quite. Yeah.
Yeah, because this piece is transitioned here and it's not over here.
Yeah.
And this piece is it's not even a double. It's not even a double inversion. So yeah, this is why when we plot it and graph it, and show them in 2 different colors, you can see and just focus on this whole section. It's easy to see it.
Yeah.
Now, I hope it's Justin on the call here, because this is important stuff that he would like to be hearing. And we're not taping this. I mean, is this being taped, recorded?
Maybe. But nobody listens to these. They don't show up. They don't show up for 2 weeks, so you're in the clear.
Oh, right. Okay.
Okay. Yeah. This is good. Yeah.
All right. Now, just while I'm
it's
sorry
okay, Michael. It's okay. We all knew that HBM4 is double HBM3, right? They just added more channels, more of the same channels, a little bit power, a lot more power, things like that. So HBM4 hasn't been that secret.
All right. Okay.
Okay. Yeah, and we still, I mean, we cannot derive anything from this, right? See how small it is.
I suspect when we finished with this, it'll be less than 1 megabyte in size.
Yeah.
So I think it's going to be pretty compressed.
Yeah, that's good. Yeah.
All right. Okay. Now, next week, David, I can craft the die stack schema, but the elements I'm thinking about, there's 8 pieces. I would have obviously a unique identifier for each die ID, so we have that at the moment. The vertical position in the Z stack, and working from the bottom up to the top, or from the top to the bottom. But normally people do it from the bottom to the top. The orientation of each layer is the upside, face up or face down. In case there is physical offsets.
Sorry, backtrack again about that top to bottom and bottom up.
Yeah. Which way do you want to lock it into one particular direction? Usually it goes from bottom up.
Yes, yeah, bottom up is
right. So will I prevent top down?
Dead bug.
No, what Michael is talking about is basically start for the stack from the substrate from interposer, and then chiplets that are being on top.
Yeah.
Right. So you always go from the bottom up, or do you ever want to go from it? Okay. So I will prevent it from going top down. Then within a particular channel, you might have a split into multi pillars, right? Where then one pillar then in one corner and another pillar is in the other corner. So you could have a physical offset for each of those. So we need to take into consideration for that. If the pillars change in size, you want to have the dimensions of the pillars on the side. Do you want to have in the index the method of bonding between one die and another die? For example, is it through TSV vias or bump connection? Do you want to?
Actually, I had a question. I was just about to ask you something about this. When you're creating these patterns, can you create a double-sided pattern?
I can create whatever you want, but you
No,
have to tell me what it is you want.
Meaning one part has patterns on both sides of the die.
Yeah, why not?
What's the flag to tell you which side it is on? Is there a flag or something right now?
Right now, you can have. Remember when you go back and you create the terminal patterns, right? So you group all of that into a pattern and you give it a position. And that position could be on the top side, and then you create a new pattern, and that position could be on the bottom side. So now you have top side and bottom side of the component.
Yeah, sorry. Maybe I'm missing something here. Probably I'm missing something here. I thought the position is XY only.
No, you've been asking me to put in a position for Z. So now we're going to do the Z. Now there is a little bit of 3D of a Z structure in there, but it's not in the sequence that you want. And you also told me that you don't want a Z dimension to be specified in millimeters, because after you do all of the compression of the stack, the post process and the pre-process Z dimensions might be different. So you said put it in order of an index. So this die is first,
Okay.
followed by.
So
the question
the way,
I have. Yeah.
So Michael, the way I'm thinking about this is, I think the way I'm understanding what you're saying is that we are going to create a many different patterns, right? For 3D stack chips, we are going to create many different patterns, and just we are going to be changing the Z height. Did I get that one right?
Yeah, the patterns is totally separate to the Z height. So the patterns is one thing, the Z height is a different thing. So should you want to define the Z height in millimeters, then you're going to have to think about, well, do I specify those dimensions before the processing happens or after the processing happens? And then what happens when you have different manufacturing processes that could lead to a different Z height? And I think for that reason, you said don't put in Z dimension in the form of millimeters. You said put it in the form of index, as in this die is in this position 0, and the next die on top of it is in position 1, and so on all the way up to the top.
Yes.
Right. So my question, I have a question in that area is between die, the bottom die and the next die above it, you have an interconnecting layer. The interconnecting layer, do you want to specify anything about that interconnecting layer? And maybe it's a die on top of a die with no interconnecting layer, because the bumps on the bottom side of the top die matches exactly the bumps on the top side of the bottom die. In which case, it's a die-to-die direct connection without an interposer.
Oh yeah, it's my answer is we don't need to worry about that. If it's an interposer, if it's an interposer, or any other connecting layer, that layer would become a part model with pins on top, pins on bottom, and then it will become part of the stack.
Okay, so considering each die is its own individual part model, when I create my stack, I'm just pointing to this part model after this one, and I don't really care now what the part model is. So if I have in the sequence of the index, three part models that I'm referring to, and each of those three part models are dies, then you would expect the patterns of each of those dies to be directly matching the respective pattern on the other side.
It will be, so on the layer, on the interface between layers, those things will be directly matching.
Yeah, and if in the event that you had an interposer in between, then the pattern on the interposer must match exactly the pattern on the die.
Yes.
Yeah. Okay. That's straightforward enough. Yeah. That sounds simple. Is there ever a situation?
Michael, just one on that one. I'm just bringing it out loud. How many of you are familiar with Deca Technologies adaptive patterning?
What's the question again? How many of us are familiar?
Not you. I don't expect you, but maybe I'm more targeting towards David Rashkov. David,
I am.
With, Tony, you are. I know that.
Yeah. Yeah.
So basically what they do is based on the die, the inaccuracies in die placement, rotational accuracy or translational accuracy. They actually on the fly, based on the placement of the die, readjust the routing layer to make sure that the connectivity is matched, right? That's their, so they do inline scanning and look at the scan result of it and go and adjust the substrate routing. Now, why I brought that up is because eventually what will happen is when you're shrinking the bump pitches and the interposer will be very tightly integrated, right? So now what you said, there could be a misalignment there. And if Deca is at all ever going to target that misalignment through creating notches or creating routes in this case to map the interposer with the die, then we should be ready to support that. But why did you ask that question, whether the presence of a route there matters or not? Michael?
I think what Michael, let me answer. I think, Pratyush, what you're describing is a manufacturing level thing that they do, meaning in the design process, I assume that everything is lining up, right?
I see.
Right. I'm designing that these bumps are going to line up with those bumps, and I'm just going to place things on top of each other, right? Now, true in manufacturing, that in life never happens, as things happen in software, so they need to adjust and make that alignment happen. But I don't see off the top of my head what we need to do in this to describe that, right? I don't see the relationship.
Well, yeah, and CDMXML, if I'm not mistaken, also has provisions to describe tolerances on the placement of all these objects. Correct, Michael?
Well, today. Yeah, I guess we have to make sure that's the place. So you're talking about when I assemble two dies together into one.
No, I'm talking about in the die definition, right? We have pins and there's locations, but those locations are ideal, right? But in the real world and to reflect manufacturing, I thought we had provisions to be able to describe the tolerance. Yeah,
of course. If it's within the die, you have all of that. Yeah. But I'm also assuming that when you stack the dies, you will have a tolerance of placement during the stack.
Right. So in the placement, there's a tolerance. There's a tolerance on each of the pins and each of the components, right? So that's all information that, you know, is superfluous when you're doing CAD layout, but it becomes relevant when you're doing assembly.
Right.
Yeah.
So
But-
I think
Tony, even those tolerances, at least in the case of that technology, it's not even relevant, right? Because it looks at what it actually ended up being, and will adjust things, right? So how accurately you did the bumps, it doesn't really matter, right? It will pick it up. It will actually optically see what it is and will adjust things.
Well, that's what the adaptive patterning does.
Yes.
Yeah, no, I'm saying, but if you don't have adaptive patterning, you know, when you're doing assembly and routing, those are things that you need to make sure your equipment, your assembly equipment has, you know, understands that and can deal with it, right?
Yes. Yeah. And Pratyush, on the second question, what Michael was talking
And
about.
that is something that I don't believe is supported in 3D blocks, right? They're just dealing with ideal geometries.
Yeah.
And the other thing, and again, correct me if I'm wrong, because I'm saying this to people publicly, is we also have the ability to describe the 3D shapes of the pins, correct? So if it's a copper pillar and if it's a squish ball, we can just describe that in the schema, correct?
Yeah.
Yes.
Okay, thank you.
Yep. Yeah. So Pratyush, what Michael was talking about is looking from pure format definition. What happens if, for whatever reason, the bumps on top and bottom dies do not necessarily align, and if there is an interposer in between, and some of those people that talk about microfluidics and things like that, they envision a layer in between chiplets that's going to carry heat out. So there is going to be definitely a layer in there, but that's going to be a part, and but still for that part, interfaces on both sides they have to line up with the interfaces on the chiplets on both sides, right? That's the only way to make the connection. Now, whether they reroute some of the signals left to right or things like that, doesn't really matter, right? As long as the interfaces line up, we're good to go. But typically, Michael, nobody would insert a layer. Actually, I guess somebody could, but it's not typical for somebody to insert a layer in between just to reroute signals. That's a very extreme thought.
All right. So the reason why I'm asking this is earlier you guys at one of the previous meetings we talked about the effectiveness of having these compressed data structures, and if you have a bump pattern on the top side of die in position 1 that is connected to a bump structure in the bottom side of die number 2. Now, how would you analyze that the two bump structures should be the same? Would you split it all out into individual XY coordinates and then do all the die? Or would you compare pattern to pattern? And so if you, I don't know the answer to that. That's the software guys to go figure that stuff out. But now think of if you had a reroute layer between die 1 and die 2, and you did not have that specified in the part model, then you could be inherently failing your stack up because you don't know of the interrouting layer and you don't have the routing layer defined. It might be defined in a different file, and that's why I'm saying in the index for the stack, do you want to have the routing layer to be defined?
Hey, guys, I thought this was the test chip meeting. Did we talk
Yeah.
about, can we do a
Yeah.
quick status update on where we're
Yeah,
at?
yeah. Let's. Yeah. Let me just answer the question from Michael. I think Michael, the question is still like before, meaning no, that a routing layer will have to be defined as a part.
Right. So in that case, that means that it's a separate part model.
Yes.
Yeah. And that's all I needed was that
Yeah.
was that. So we're fine then. It's just we
Yeah.
just treat all the stack as individual part model files.
Yeah. It
Okay.
will have to be that way. Yep.
That's very
Yeah.
good.
Okay. Oh, okay. Let's switch to the demo design. I touched base with Patricia. She would not be able to present to us today about the stuff they have done. So maybe next time. Now we can switch to Singman and see what you have been up to.
Yeah. So today I couldn't bring the updates. I'm still figuring out the how to integrate the netlist
Okay.
to create the logic and memory. Because yeah, it's pretty. I'm pretty busy for ICCAT submission.
Oh yeah.
The due date is April 22nd, so I might be quite busy for that for 2 weeks.
Okay.
Yeah.
Okay. Yeah, that's fine.
Yeah. Yeah, and I'm also in quite complicated situation. Yeah.
Yeah.
As I said yesterday to David, uh my advisor, Dr. Lim, will move his school to USC in California. So
Yeah, we
I
did hear that. So he's physically has moved.
sorry?
So he's currently has moved to California. Okay.
He will move from
Right.
from this fall semester, but he will start moving from May, maybe. Yeah.
Okay.
I
Thanks.
see. And do you have to find a new advisor, or you?
Yeah, I'm actually finding new advisor in Georgia Tech.
I see.
And yeah, so
Okay.
yeah, the problem is summer funding. So yeah, it's quite overwhelming for me. Yeah, but it's
Very
okay.
stressful.
I see. Understandable. Do you work with Professor Bakir?
Oh yeah, I'm trying to join his lab, and I
You
I
want
actually
to
met him yesterday, and but he has a new project, but it's not the contract is not done
Yeah,
yet.
we're part of that project. So
Oh, NAPMP.
let's talk offline.
Let's
Oh
talk
yeah.
offline, Sungmin. Yes, yeah, we would not waste losing you actually here, so we can talk about it. Yeah.
Thank you.
Okay. Yeah, thank you guys for helping Sigmund on this. I think he's been very valuable to our effort and would suck big time if we lose him.
Oh, thanks for having me out.
Yeah.
Yeah. I'll do my best. After the ICK submission,
Okay.
on this demo design. Yeah. And
Okay.
yeah, I might be able to focus on only on this demo design after during the summer, because I don't have any other projects this summer. So yeah.
So, did you work with Professor Lim also on the glass related stuff he was doing and the automated place and route solution, whatever AI based solution he was looking at? Were you exposed to that work?
After can you second, please?
Let's take it offline. I'm sorry to keep this meeting focused. Let's take it offline, Sungmin. Maybe you can.
Oh yeah.
Yeah, we can talk separately.
Okay, of course. Yeah.
Okay. That's good to know. We wish you good luck with your submission at ISACAT.
Yeah, thank you. Appreciate that. Yeah.
Where is ISACAT this year? I think you told me and I forgot.
It's in Munich.
Oh
Germany.
yeah, Munich. It
Yeah,
was around Oktoberfest.
Yeah,
if I
October,
remember
yeah.
correct.
Yeah.
Okay. Yeah, Munich is a nice city.
Yeah, hopefully I can go.
Yeah.
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 Okay. Yeah.
Yeah. We wish you success in that. I don't know if anybody at ISACAT to help with the approval, but I'm sure it will be okay. Okay.
Thank you. Yeah.
What else is on your minds today? If nothing, we can wrap up early. I can get some more coffee before my next meeting.
Yeah.
Okay.
Okay. All right, everyone. Thank you very much for joining today.
Okay,
Michael,
thank-
I'll send you offline email. Let's see when we can talk next week. I'll have to look at my calendar.
Right, okay,
All right.
very good. Thank you, guys.
All right.
Thanks,
Thanks.
everyone.
Bye.
Thank you.
Bye.
Oh, short. Wow. What's going on there? Different boys. Interesting. Okay. That's a good sign. $740. $740. Okay. it should be E. No. Don't want to do that. Let's see what's going on here. 4, 2. I should probably do this. Say by Microsoft. Or Google. Let's go Google. No. Uber. Okay. So that's fine. Okay. Holy shit. Wow. Welcome. Really? That's it? What? I would think it'd be a lot higher. Wow. That doesn't seem right. Okay. Shit in the bed. What? XOV, huh? Really? Huh. XOVR. SpaceX. 15.48. Oh, well. Thanks. DJT. All right. Ugh.